Okay, good evening, everyone, and welcome to the 10th dialogue of the Breathe In series. The Breathe In series is organized by us at Environmental Design Solutions. My name is Dipanjali, and I'm joined by my colleagues Lakshmi, Nidhi, and Farana. And we are thrilled to have a distinguished panel of speakers, Dr. Jeffrey Seigel and Dr. Dusan Licina. Thank you so much for joining us today. The Breathe In series is a platform where we discuss about indoor air quality, why it matters, the challenges around it, the current challenges around it, and basically what we can do about it. It's really about learning from each other, sharing experiences, and hearing from experts all around the globe who are leading research and action in this space. Our topics evolve around four themes for aspects of indoor air quality, mainly regulatory convergence, design and technology, monitoring and management, and occupant awareness. We have had very interesting experts all over the globe on these dialogues. They have shared their insights on a wide range of topics, ranging from indoor air quality standards, audits, to new technologies and innovations, and certification systems related to indoor air quality. We have explored how indoor air quality plays out across different building typologies, whether it's residential spaces, healthcare facilities, schools, or even commercial buildings. So we all breathe the same air inside a building, but because we can't touch it, we often forget it's there or often assume it's safe. We have seen an increased awareness about different sources of indoor air quality. Say, for example, the indoor air qualities in an office space like this have several sources of indoor air pollution. The HVAC system, if not maintained properly, can, um, you know, um, can circulate dust, allergens, or even chemical pollutants throughout the space. Pollutions from outdoors can find its way through windows or leaks in the building envelope. Wall paints and furniture like desk, chairs, or even carpets of gas volatile organic compounds into the air for several days or even months. And every time we use cleaning products, we are adding another layer of chemical exposure into the environment. Well, improving indoor air quality is completely achievable. All we need to do is manage emission and contamination generated indoors and protect ourselves from pollutants that come in from outside. Some key strategies include increasing ventilation and filtering the air to dilute pollutants, monitor and displaying of indoor air quality parameters to stay informed and take necessary actions. Choosing low emitting paints and now even low emission furnishings reduce chemical exposure. Plants, when chosen and maintained carefully, can improve the quality of air. We often hear that these solutions could be complicated or very expensive, but in reality, it's all about knowing when to and how to apply these solutions. Today, Dr. Siegel will talk through the barriers that still stand in the way of widespread adoption of air cleaning technologies and how we can bridge those. While Dr. Dusan will help us to understand how continuous indoor air quality sensing, powered by IoT and smart analytics, is transforming how we manage and measure indoor air quality in real time. You can look forward to an engaging discussion with our experts and participate in interactive session. So please feel free to use the Q&A function to ask questions and share your comments. We will also be launching a few polls during the session. So these will pop up on your screens, and it will be a great way of to understand your perspectives and experiences as well. So with that, I would now like to introduce Dr. Jeffrey Seigel. He is a professor at the University of Toronto, and internationally recognized for his work on indoor air quality mitigation strategies, and comes with an enormous research background on cognitive impacts of indoor air quality and the impact of building systems on indoor microbiology and chemistry. We are very happy to have him here. Welcome, Dr. Segal.
Thank you very much for the invitation to be here, and I'm really kind of grateful for the opportunity to talk with everyone. As was said in the introduction, I want to talk a little bit today about both the challenges of using filtration and air cleaning strategies for indoor air and how we might overcome some of those challenges. So I want to start with a couple of questions, and the first one is on the screen now. When you think about your home, what is your biggest source of indoor air pollution? Let's see. So two categories here obviously have the most, and I think that the reason I like to ask this question is before we even talk about cleaning the air, I think it's really important to think about where air pollution is coming from. And the other thing that I think is important to realize is that every individual is going to have different concerns depending on the environment they're in. Let's move on to the second question, and just oops, and would like to know in the audience how many people or do you have and use an air cleaner of some sort in your home? So you can see from the results, I think what I see relatively typically, a lot of people don't have one, and then a smaller distribution of some of the other answers. And I think it's really important from the perspective of this talk to kind of think about why that is, why people should people be using filters, and why people do and don't use filters. So with that as background, I know many people have probably been to other sessions in this series before, but I think it's really important to situate air cleaning in the broader context of indoor air quality. So what you see here are the four kind of central tenets of how do we improve indoor air quality. And the first one is keeping things dry and avoiding a moisture problem. And you can see lots of writings on this. What I just put on the screen is a long chunk of text from Leviticus in the Bible. And it's not important to read this text, but it's important to recognize that if you go back thousands of years, people were talking about, pretty much as long as we've had buildings, people were talking about moisture and moisture problems in buildings and what to do about them. So a long history in indoor air quality. After keeping it dry, there's this concept of source control, which means getting rid of indoor sources. The person who's on the screen is Dr. Pettenkofer. He's a German hygienist who was responsible for a lot of work in the 1850s and 1860s about kind of acknowledged as the great-great-grandfather of indoor air quality. And he has lots of pithy quotes like the one on the screen. You know, if you have a source of indoor air pollution, don't try and ventilate away the source, get rid of the source itself. And that's still very true in indoor air. Of course, it's not always possible. We have many sources, as you just saw in the introduction, that we can't easily get rid of. But that is kind of the bedrock or a key aspect of indoor air quality. Once we've gotten rid of sources that we can, the next thing we should talk about is ventilation. So the two people on the screen are Catherine and Harriet Beecher Stowe. They wrote this very popular book, a bestseller in the 1860s and 70s in the US about the domestic realm. And if you look at this book, there are two chapters all about indoor air quality, one of them on health and indoor air quality, and one of them on ventilation and the importance of ventilation. And similar to Dr. Pettenkofer, they have lots and lots of kind of pithy comments in this book. By the way, this book is publicly available and it's worth looking at. But they talk about how important indoor air is. And in the quote on the right, they talk about how important ventilation is and how important it's one of the most important things in maintaining the domestic realm. And then we get to the subject that I'm going to talk about today, filtration, or more broadly, air cleaning. And the only point I want to make about filtration is that compared to everything else I just talked about that has a history of hundreds or thousands of years, filtration and air cleaning, at least in the way we use it in buildings, is got decades of history, a very short history. Originally, filters were used in industrial processes to keep parts of air streams relatively clean. Then we started using filters in buildings, nothing to do with health, really more about keeping the system clean and free of big debris. And if we think about modern filtration standards, standard 52.2 is one example of a modern filtration standard. It just turned 25 years old last year. So it's a very new thing compared to everything else. And it doesn't have the same history, which is why it's so important to talk about it. So if you've attended other lectures in the series, you know that indoor air is very important because we spend our time inside. There's all these sources inside. There's outdoor air pollution that comes inside. Of course, we've all just lived through the pandemic and know the importance of indoor environments for infectious disease transmission. And if you look globally, there's these great increase in these kind of ambient air pollution events, things like wildfires, hot spots of poor outdoor air quality. And because we're also living closer together with increasing population, especially in many big cities, we're seeing more air being shared between individuals. So indoor air quality is very important. And within that context, filtration and air cleaning, a really important point to get on the table right away is that we know filtration works. It reduces exposure to particularly particulate matter, and we know that that has positive health effects. So one example of this is the National Academies of Science, Engineering, and Medicine came out with this report earlier this year on practical mitigation of fine particulate matter. And there are many, many papers referenced there, including several review papers that show that filtration does improve health outcome. The summary in this report about filtration and air cleaning is that this is a very effective way of mitigating exposure to fine particulate matter, which is associated with a bunch of health effects. But there's also a lot of variation. So sometimes filtration has a big effect, other times less so. And I think it's really important to talk about that variation. One last point before I kind of get into the heart of the presentation is ASHRAE, which is the main professional society that deals with heating and cooling systems and by extension indoor air quality. These are some quotes I put on the screen from the ASHRAE president. And I won't read them all, but you can see that they all highlight the importance of indoor air quality. And the one at the bottom of the screen, the issue of indoor air quality is a sleeping giant whose time has come. Well, Donald Banfleth, the then president of ASHRAE, made these comments in 1986, so almost 40 years ago. And I think that if we look, realistically, we have not greatly improved indoor air over the past, few decades. And so the point of this presentation is why in particular aren't we using filters which we know work and have positive health outcomes to improve indoor air. So now I want to come to another question. Before I tell you why I think we're not seeing use of filters to improve indoor air quality, I'd like to hear what your opinions are. And so is it economic? Is it knowledge-based? Is it technical? Or is it something else? Interesting. So all of them are there and are represented. And of course, the answer is it's got elements of all of the above. But I think it is really important to, before we address, kind of how we can increase the use of filters, we have to understand why maybe they're not being used as much as they could. So I'm going to focus on three challenges and opportunities to overcome each of those challenges. I think we have to do a better job on the kind of knowledge translation, especially the benefits of using filters. We have to actually demonstrate that filters are working in buildings, and we have to do much better job at communicating how to use filters well. So first, let's deal with the first challenge, the economic challenge. If you think about, why people might not have an air cleaner in their home. First, like with everything, there's an overwhelming number of options. So there's kind of a choice paralysis in buying an air cleaner. Of course, air cleaners themselves, depending on where you are in the world and what type of air cleaner you're buying, can be quite expensive. But even more so, about 90% of the total cost of ownership is in those filter replacement costs. And so that ongoing cost can be a barrier for many. And again, filters tend to be quite energy efficient, but I think there's certainly a perception that the energy is important in running the filter. So that's how people look at an air cleaner. There is these big costs associated with it. But the reality is, if we put those costs in context, so what this shows is several articles that look at the benefit to cost ratio. So how much benefit divided by cost. These are articles from different places in the world. The squares here are residences and the circles are office buildings. And what's on the x-axis doesn't matter that much. That's a scale of efficiency where a higher number is better. But the overall central message of this work is that these different authors who have taken different approaches to assessing the benefit to cost ratio have found a kind of 10 to 100-fold benefit over cost. So what that means is for every dollar we spend on filtration, we get 10 to $100 of economic return. And I think that we focus on the cost number, but we should really be looking at both the benefits and the cost. And I'll come back to this point, but most of that benefit is in avoided healthcare costs, which is a big number in much of the world. And so really, we have to do much better talking and understanding the benefits. And I think a lot of times we focus on the health benefit, especially the chronic health benefit of using filters, but there is so many benefits to filtration that have been documented in the literature. Everything from improving cognitive performance and learning, specific benefits in schools, reducing absenteeism, for example, and many other benefits that have been documented in the literature. And as one measure of that is the picture that's on the right of the screen. This is some work done by Donna Vacalis, where she looked at schools specifically and looked at what the evidence basis was for improving air quality in schools, focusing on cognitive function, standardized test scores, and absenteeism. And what you see is that there is a lot of evidence in the literature of various strengths, of various qualities that show that many of the things that we might do to improve indoor air quality have been demonstrated to have positive benefits. And so it's not just health we're talking about, it's a much wider variety of other benefits. And I'm from Canada, and in Canada we have communities in the north of Canada. And one of the things that we see as a potential benefit for filters that hasn't really been used is when we have health impacts that could be lessened by the use of filters. So RSV is a virus that mainly affects very young children, babies. And what happens when an individual in one of these northern communities gets RSV is they have to be medically transported to a hospital that can treat them. That is quite expensive. It's done by helicopter. The treatment itself is a pharmaceutical treatment for RSV. It's quite expensive. Because these are babies, the family comes along. So the family has to be housed while the baby is getting treatment. The parents obviously can't work because they're there with the child. And you end up disrupting schooling for the siblings of the child very often. You disrupt the communities because people are leaving. And so I'm not saying that filtration is a magic solution, but it's a good example where if we could reduce the incidence of RSV, which is an airborne virus, by the use of filters, we get all these economic benefits and social and other benefits by the use of filtration. The other comment I want to make about filtration, or the other challenge, is that filters work differently in different environments. And so if you look at the in situ or real world performance, it varies a lot. And some of this stems from the fact that we test filters in standardized approaches, different standards in different places in the world. But if you look at the actual performance of the filter, it's a function of a whole lot of variables beside the filter itself. So as one example of that, this is some work here that reports the effectiveness, how well a filter is working. There's about 16 studies represented in this figure. And again, that scale at the bottom is a measure of efficiency. And what you see here is there's not a lot of structure to these data. Sometimes a relatively low efficiency has a relatively high effectiveness. Other times a relatively high efficiency filter has a relatively low effectiveness. And this happens because of the context, how that filter is being used in the building. And so one of the challenges we have is we can't just say use a good filter because you won't always get good performance. And so I think we really have to work on the communication aspect of things. We have to tell people how to use filters. And what's in the red box is a summary of you first select a good filter based on those standardized tests. You have to make sure that a lot of air goes through it. Turns out that the amount of air is very, very important to the filter. You have to change that filter when it needs changing. Otherwise, its performance will often decline. And you have to verify its performance, make sure it's actually working. So it's a little bit more complicated story than just getting a filter. You have to use it well. And one of the things that my group has been working on is how do we actually measure how well filters are working in real environments? So what you see here are two different air cleaners. The one on the left is a smaller or lower performing air cleaner, and the one on the right is a higher performing air cleaner. And we took that air cleaner and we put it in 5 different environments. Took those 2 air cleaners, put them in 5 different environments. A couple of residences, and then a couple of and then a few non-residential environments. And then we measured their performance in a very simple way. We turned the air cleaner on for a couple hours, ran a placebo for a couple hours, switched back to the air cleaner. And what you see here is that effectiveness, how well that air cleaner is working over that 2-week period. And, there's 2 things I'd really like you to get from this picture. One thing is some of these distributions are quite wide, which means sometimes an air cleaner can perform very well in an environment. Sometimes it can perform not that well or quite poorly in an environment. And so what's going on with the air cleaner is really important. But the other thing for both of these air cleaners is you see a spread of performance. So for example, for the figure on the right, you see in some of these environments, the air cleaner is performing, 80 to 100% effectively. So quite effective on average most of the time. And in other environments, the air cleaner is 50% or lower on average in effectiveness. And so there is a real process we have to go through here to check to make sure an air cleaner is working well. And I hope that this type of approach becomes much more standardized and common so that we can actually understand how air cleaners are working. And of course, Dusan is going to talk shortly about indoor air quality monitoring. But I think that the comment I want to make about low cost and other forms of indoor air quality monitoring is we have a real opportunity to use these low cost devices to make sure that filters and air cleaners are actually working. And if they're not working, to understand what the deficiency is and correct it. And the one comment I'll make, because I know Dusan will do a much more thorough job, is that I think we need to not just think about measuring the pollutant, we need to think about the interpretation of that data and how we're sharing that with occupants of indoor environments. And then the last challenge I want to talk about today is the fact that we have both about indoor air quality, kind of an absence of good information and then some amount of misinformation as well. And fundamentally, in most of the world, indoor air quality is not regulated. And not only that, there's a little bit of a barrier to talking about indoor air quality because we all like to think our homes and our buildings are sanctuaries. And of course, we know that there can be many pollutants in our indoor environments. And that also some of that indoor air pollution is caused by us and our activities. And in most of the world, there's not a government agency that has a kind of complete mandate to address indoor air quality. And consequently, we don't always have all the scientific answers. So in the world of air cleaning, there is a lot of misinformation by manufacturers of air cleaners. There's a lot of kind of what I'm going to call alternative or unproven technology air cleaners. And there's a lot of issues throughout history of where people have promoted air cleaners and kind of do some not so good testing and then use that testing to make the argument that they work well. This has led to a variety of lawsuits in recent history, but we see a lot of headlines. This is from 5 years ago or so, where there's a lot of claims that air cleaners are magically cleaning the air of things that we might worry about. And this has led to lawsuits when people challenge that. And so we have this big part of the industry that's talking about air cleaners, working certain kinds of air cleaners, and maybe they don't work as well as we might think. And so I think we have a real opportunity here to counter misinformation. And two examples of that I've been involved with is one with a group of individuals. We've been trying to challenge in some of the information that's being put out by government authorities when it's not quite correct about indoor air quality. So there's a couple of examples of articles there. But of course, a lot of the world doesn't read scientific publications. So this is another effort that we've been involved with, where we recognized relatively early in the pandemic that there were some organizations, community congregate settings, things like homeless shelters and group homes, that sort of thing, community health centers, that weren't being addressed in guidance about indoor air quality generally, about COVID-19 specifically. So we started office hours where we could meet with these individuals. We developed a checklist of how to address indoor air quality in their spaces. We came up with some guidance. We had pretty terrible wildfire smoke in 2023 in the part of Ontario that I'm in. And so we developed this guidance. We meet with these organizations, and I think that type of approach can be very helpful for not just countering misinformation, but providing good information to work with people. And I want to make the point as well that if you look throughout the world, there is good information being provided. This is from Hong Kong. There's a federal level agency that provides information on indoor air quality. They have many of these kind of plain language guidance on different aspects of indoor air quality. There's about 20 of them, about 15 are shown here. And some of them are general, address indoor air quality general. Many of them address either specific environments or specific pollutants. And I think we need more of this type of approach to really provide people with the information they need. So I'll wrap up here by saying that the benefits of investing in indoor air quality far outweigh the costs. And filtration is one very kind of cheap way to do that. And our challenges are a lot more about implementation than they are about the technology. We need to get, I think, a lot more sophisticated and better about overcoming those barriers. But I think the last message I'd like to leave you with is that there's a lot of opportunities here to make a change. We have a lot of opportunity to improve indoor air. So I'll finish there. Thank you.
Thank you so much, Dr. Seigel, for highlighting general perception of indoor air quality, the current barriers and challenges, and the benefits and opportunities in this space. So thank you for also highlighting some interesting examples. For any questions, please use the Q&A box and we can address it during the moderated session as well. We now have Dr. Dusan Licina. He is an associate professor at the EPFL and serves as the director of human-oriented built environment laboratory. His research focuses on sustainable and healthy building environment, the dynamics and science around indoor air pollutants and building ventilation with minimum energy use. Welcome and over to you, Dr. Licina.
Okay, so it's a great pleasure and honor to be invited to share some thoughts on the topic of continuous indoor air quality monitoring. And also it's a great honor to speak alongside Professor Jeffrey Seigel, and also big shout out to the organizers for putting together this interesting dialogue series. And I managed to catch some of them in the past, and I also look forward to those incoming ones. So let's talk a little bit about continuous indoor air quality monitoring. I'd like to start by asking a broad question: why indoor air quality monitoring is important? Well, there are many reasons. First, we live in the era of climate change, which of course gets manifested in many ways: severe weather events, extreme temperatures, wildfires, new pollutants, and WHO basically says that majority of the world's population, about 99% of the global population, breathes air that exceeds the air quality limits. We also have an issue of household air pollution, which is, of course, the major contributor to various illnesses. And we have more than 3 million premature deaths annually. And most of that, in a way, is happening in India, in fact. And as we all know, we are facing a more and more frequent occurrence of global pandemics. And considering that, of course, many of these infectious diseases are airborne, this is certainly an indoor air quality problem. So coming back to my question, what is the role of continuous indoor air quality monitoring in overcoming these issues? Well, one of important steps to overcome the issue, of course, we need to be able to quantify various aspects of indoor and outdoor environments, and low-cost continuous sensors have the potential for understanding and overcoming these issues through making the invisible become visible. But also beyond solving all these important problems, we are not only interested in solving issues, but also this dynamic evaluation of indoor air quality conditions can help us also gain insights into what is happening in our buildings, and that can be used to actually promote human thriving. We can improve comfort, health, productivity, and overall well-being. So my objective today is to explore challenges and opportunities associated with continuous indoor air quality monitoring. And I'll begin with just a brief overview of what we know about continuous air quality monitoring. What are the challenges we are facing from the research and technological, maybe even legal perspectives. And I'll try to summarize with a brief outline of the envisioned future. So let's start with what do we know at the moment. First, I think it's very important to set a stage with some important caveats on indoor air quality monitoring. So Prof. Seigel talked about the long history of ventilation, and then somewhat shorter, actually short history about filtration. When it comes to continuous indoor air quality monitoring, we talk about extremely short history, in fact. So this is a rapidly growing and changing field, and what is relevant today might actually become obsolete in the next several years already. I also want to point out that there is more research available for continuous monitors outdoors, way more. And also, unlike outdoor air, which has been traditionally monitored for air quality, there are no routine monitoring of air quality in indoor environments. And pretty much the same issue applies to the monitoring networks that operate with low-cost air quality sensors. So I think this is very important to set a stage. And I also would like to share a couple of definitions, because definitions can indeed vary from field to field, from person to person, and there is no single internationally agreed definition of these terms. So just to set a stage, the reference instrument, it's essentially associated with the reference method. This is what we often refer to a lab grade instrument. Then what is the monitor? So this is an integrated device that comprises of at least one or more sensors. And it's also, there are other supporting components which are needed to create a functioning system. Then a sensor itself is a subcomponent of a monitor. And finally, what is the difference between low and high cost? Well, the high cost are for lab grade or reference grade instruments typically range from a dozen of thousand USD, whereas when we talk about low cost monitors, at least in Europe and in the Northern America, typically it's below 1,000 US dollars, and then the sensor component itself can be below 100 USD. So I'm going to be focusing on these underlined bullet points. There are multiple phases of implementation of low-cost continuous sensors. There is a selection and assessment of sensors and monitoring devices. Then it's important question how we deploy them. Do we deploy them individually? Do we deploy them as a network? Are they stationary? Are they mobile? Can they be wearable? And then it comes to data. This includes data exploration, storage, security, communication, analysis. And finally, what do we do eventually with this data? Do we produce new knowledge? Do we raise awareness? Do we give feedback to building occupants? Or do we loop this information into automated control? One important takeaway from this slide is that if one component or one phase of this implementation is missing, everything is likely to fail. So we need to handle all these points together, for which very often a multidisciplinary team of people is needed. So this presentation, I'll be touching on various points, but not necessarily to all points. So let's start with the full question number one. Is more data always better when it comes to indoor air quality? Yes, not necessarily. It depends, or no. So I'm going to share a couple of questions, and of course, there is no one, straight correct answer. So there could be multiple correct answers. Let's have a look. It's in a way split between it depends and yes. Nobody thinks it's no. I would personally respond with the C, it depends. Because more data, of course, it's powerful, and we currently certainly need more data, but this data needs to be usable. And in indoor air quality field, if we have access of unfiltered and poorly contextualized data, this data can actually very easily confused rather than bring new knowledge. For example, if you have a PM level data at a very refined second by second level distributed across 50 zones, this can be impressive, but without actually clear interpretation, what are the thresholds, what are the response mechanisms, this can actually end up just as a background noise. So we always need to prioritize quality over quantity, especially when we have constrained resources, as usually is the case. But speaking on this question, let's see what do we have in practice. I already gave you a hint. We currently actually have quite limited coverage, both outdoors and especially indoors. This is an example of current practices. For example, if we look at EPA, they have distributed networks that certainly do not capture true exposures, because we know that air pollution concentrations, both indoors and outdoors. Here, I'm just giving an example for outdoor environment. We know that concentrations are extremely refined and that they have numerous hotspots. So we certainly need more dense and refined network of monitors than what we have today. So, and the question is where we are now and where we, of course, need to be. The current practices for indoor air quality continuous monitoring, they're characterized, well, there are not too many initiatives. What we have is rather practices that are sporadic and episodic data sets. We have this generic solution rather than place-based solution. And when performance verification in buildings is happening, usually we still rely on reference grade instruments and the expertise, expert knowledge, which is of course quite rare and expensive. So this is in a way what we currently have in practice is more of an industrial hygiene approach. So in terms of where we are now, of course, the guidelines that we have are largely prescriptive. They're not performance-based. And we have many examples for that. For example, minimum ventilation rate standards. But also there are some early experiments with adding continuous monitoring as part of an effort to make buildings more performance-based. Yeah, at the moment, this is still quite a limited effort. And there are, of course, some good reasons for that. It's important to answer the question why we're not yet where we are supposed to be when it comes to routine continuous air quality monitoring. Well, we need to recognize that gathering good data set is difficult. And there are, for example, multiple degrees of complexity of measured indoor air quality parameters, whether we talk about temporal variability, spatial variability. For particles, there is a broad size range, shape of particles, but also air pollutants come with distinct chemical and biological specificity. And there is no single monitoring technique that can tackle all dimensions of complexity together. This is the case even for high-grade monitoring and, of course, especially for low-cost sensing. And in addition to these physical constraints, there are also other constraints, physical access to spaces. We need to make sure not to invade the personal spaces of people where they live or work. Yeah, we often, as I mentioned, we don't know really what data is relevant. And last but not least, it comes with a cost as well. So these are some of the kind of what we know at the moment. But I would like to also give just a snapshot of the several types of challenges that we are facing. I'm not going to go in details because of the time, but we do face a range of scientific, technological, and legal institutional challenges. And some of these can be solved actually with relative ease, and some of them actually are more fundamental issues that require more fundamental restructuring. So let's start with the poll question number 2. Is it more important for indoor air quality data to be accurate or interpretable? What matters more, accuracy, interpretability, both, or it depends? Okay, thank you for voting. Majority of you think it's C, both, and I would also agree with that. If we have very accurate but opaque data set, that is not very helpful. But on the other hand, also having very intuitive data, but that is misleading, it can actually be quite dangerous. So we need a balanced and tiered approach. For scientific analysis and controls, we need high precision. Yeah, we can have actually more interpretable outputs for everyday users. So, for example, if we have a CO2 sensor with an error of 50 or 100 ppm, but it can still actually prompt window opening and actually have a real world impact. This is, of course, much more useful than having a super high precision CO2 monitor, which is stuck somewhere in inaccessible dashboard and not seen and used by anyone. So what is the general accuracy? So generally, low-cost indoor air quality sensor data is considered sufficiently accurate for raising awareness, evaluating trends, and guiding certain actions. But they also do face certain challenges, typically calibration drift or lack of context. And this can, of course, limit precision and applicability, especially in the high-stake applications. Also, there are different approaches how we evaluate sensor performance. But what is interesting, if you look into the literature, only about 10% of the studies refer to established protocols. And a lot of studies actually develop their own approach. How do we assess the performance of a sensor? And there is a variable judgment criteria. What is good enough sensor? Also, a majority of studies have utilized methodologies to test low-cost sensors. Most of them are happening actually on a very short time scale. So the question is it possible that the response of indoor air quality sensor is actually representative for this short time period of the testing? Because there can be aging of the sensor, there can be drift and other issues. Also, typically, we're doing measurements in the lab environments rather than in the field. This is what Prof. Jeffrey Seigel talked about as well. And also, there are differences in the methodology used. Just to illustrate this example, there are 3 studies that tested the performance of the same PM sensor within FUBUT monitor. And for exactly the same sensor, we can see the reports in this table of a very different performances. One of these studies actually was done by my lab. Another important issue, there is a lack of guidelines for continuous indoor air quality sensing. So the question is, what is the optimal sensing strategy for a building? And very often we don't really have a clear answer. At present, these initiatives are typically led by green building industry, and these are voluntary efforts. So we can pursue indoor air quality continuous monitoring if we want to get extra credits, but it's not mandated. So we're still pretty much stuck with the prescriptive and episodic monitoring practices. So the new guidelines for continuous monitoring have just started to emerge recently, but there are still several important research questions, such as how to ensure long-term performance in field environment, what is the optimal time resolution, and what is the optimal sensor space placement in a space. Of course, there are many other questions, but these are some of the most important ones. Another important issue is a disconnect between urban building and human scales. I always like to talk about this issue. And this separation between the 3 scales actually keeps the research area, the research data, and also technologies quite separated. So here I'll just give a brief example of urban building scale disconnect. So we know that when we consider air pollution of outdoor origin, majority of inhalation is happening while we are in buildings. So outdoor environment strongly impacts indoor air. But if we look into the standards, they actually rely on, for example, in ventilation standards, they rely on remote stationary measurements outdoors, which of course fail to capture different possible air pollution hotspots near our building. So in order to properly design and select a ventilation system, filtration system, we certainly need to integrate more outdoor sensor data into building design and operation phases. And not only any outdoor sensor data, but outdoor nearby sensor data. This brings me to poll question number 3. If nobody acts on indoor air quality data, does it still have value? Yes, somewhat, no, or others. Okay, we have very mixed response this time. Yes, somewhat, no. So my take is actually B. But of course, there is a limited value in unacted data. But in theory, it is still quite useful because we can identify trends. We can build evidence maybe for some future interventions. And we can also use this data to shift maybe occupant behavior over time. But of course, the true value comes when somebody is willing and empowered to act based on these data intentionally. So the goal itself is not simply to collect data. The goal is to have healthier and more productive indoor environments. So unless data feeds into some feedback loops, whether to building automation system or to occupants, the value is there, but it remains rather symbolic. So I would probably go with B. Okay, so and on this point, what happens with the data once the data is collected? Of course, millions of data points does not solve problems on its own. There are 3 key issues we are facing on the data itself. One is data utilization, because at present methodologies how to use sensor information is quite sparse. We have enormous data sets which are underutilized. Another issue is data selectivity. So the question is, can we sense the things that we really care about most? For example, we still don't have capabilities to measure some individual VOCs, SVOCs, bioaerosols, nanoparticles, and other important pollutants. And then last but not least, ease of use. So how do we enable non-experts to basically make some insights from the data? Well, we don't have too much time, but very, very briefly, I would like to touch that in addition to science and tech challenges, there are also some legal and institutional challenges which are anticipated to become growing concern in the future. So building owners, building managers, they have already expressed some concerns about some risks associated with the new sensing technologies. And they typically ask questions, you know, do new type of information create liability and duty to act? Who owns the data? How do we store data? What's the security and access? So this is another topic which certainly we should not forget about. So, and this brings us to the question, what is next, what we can expect? So for the envisioned future, I would like to just draw a parallel with the fire safety system in buildings, which is routinely integrated by default in the buildings. So my question is, can new tools enable the quantification of comfort, health, and well-being similar to the way we routinely regulate fire safety or monitor energy use in buildings? So I think we need new ways how to characterize the performance of humans in buildings. Rather than just thinking about building performance for health, we need to actually, the way we do for the building energy or materials. So we need the new ways to characterize performance of humans in buildings. And to get a step closer there are a couple of things we can actually do pretty much right now. We can replace prescriptive guidelines with more performance-based guidelines. There are some initiatives that I'm also part of in that sense. We can improve indicator representativeness and data coverage. We also need new metrics and tools for benchmarking. We need databases as well, and we need to improve data analytics and communication, and we need to converge across the data and tech silos across also different scales like human, and building an urban scale. So just to summarize, there are new exciting opportunities and also challenges ahead. And the current best of the best is still not the best. So at the moment, we do not have sensor, which is ideal for all applications. So we still need to find optimal trade-offs. Indoor air quality monitors are typically good enough for the indoor air quality management purposes at the moment. However, they're still not ready to fully replace more established methods when it comes to really high-stake applications such as regulatory compliance, epidemiology, and so on. There are a couple of challenges we're facing, and also the near future is likely to include continuous and episodic sensing with the prescriptive guideline in a hybrid mix. So we're probably going to stick with this for a couple of more years in the future. So I'll stop here and I will leave you with this closing thought. And I would like to just briefly acknowledge a good friend of mine and colleague, Dr. Seema Bangar, for contributing to the content of this presentation. Thank you.
Thank you. Thank you, Dr. Licina, for bringing up interesting facts around data sensing and what the future entails. We will now proceed to a moderated session with our experts. I would like to invite Lakshmi to please moderate this session.
Thank you, Dipanjali. I'm really excited and honored to moderate this Q&A session. This is a great opportunity to ask questions, listen to different perspectives, and gain valuable insights. So I encourage our audience to, please type in your questions in the Q&A box. We'll take as many as possible today. So without further ado, let's welcome our experts and get started. I'll start off with you, Jeff. My first question would be, many who own air purifiers could often be unsure about when to change the filters. And so I wanted to know, is there a general guideline or best practice that we could follow? And also, are there any other aspects that we need to be mindful of to make sure that we maintain these equipment effectively?
Yeah, so it's a great question, and I have to admit that the science lags being able to give a perfect answer to your question about when to change a filter. And the best answer I can give is manufacturers often provide recommendations, and then we all have common sense too. So if you change the filter and you notice that it's quite dirty, then perhaps change it more frequently when you do it in the future. So for example, I have 2 cats in my home. They shed a lot. The filter often looks awful if I change it according to when the manufacturer says, so I change it more frequently. And so that's the best answer we can give right now, with one little caveat, and that is if there is a big air pollution event, let's say a wildfire where your home is in the plume, or you have a renovation or some type of other big event, then always change the filter, because a used filter can actually cause some amount of contamination. So kind of err on the side of caution. In terms of the general maintenance, most filter-based air cleaners are quite simple and easy to maintain. They're literally just a fan and a filter. So a lot of it is changing the filter, but also thinking a little bit, this is not so much maintenance, but thinking about where it is and where it's placed in the space. You don't want it shoved up against a wall or in a corner if you can avoid it, so it has the best performance.
Yeah, great. Yeah, so we have one question for Dusan. Have you encountered any subscription-based model that could make continuous monitoring more accessible? Because even when we look at low cost monitors, it still could be quite costly for a lot of us. So have you come across such business models where we could use subscription to make it more accessible?
Well, I don't know if I entirely understood, but most of the existing, at least for commercial purposes, but most of the existing indoor air quality monitoring networks come at a they're subscription based. So and many people are asking the question, you know, is there a very clear benefit to cost ratio? The answer is yes, but we need to be definitely much more vocal in that sense, and this is something that Jeffrey Seigel was talking about. So I would say something similar can apply to indoor air quality monitoring. And of course, it depends where you are. There is quite a bit of difference in the investment cost, and that comes, you know, from the brand and the accuracy and so on. But it is possible to find more affordable solutions than the others.
Sure. Thank you. We have one question for Jeff. So the question is how the air purifiers can be tested in real world without constant concentration of pollutants.
Okay, it's a great question, and the comment I would make is that there is no one kind of pollutant that every air cleaner is going to be exposed to for all time. It changes in every environment, and it changes over time in every environment. So what a standardized test does is pick a certain pollutant or group of pollutants and expose the air purifier to that. That's an answer, but it's not necessarily a relevant answer for how you are using the air cleaner. And so part of the reason why I believe real world testing is so important is there are times when the concentration will be very low. And that's important to see because in a very clean environment, an air cleaner won't offer much benefit because it's already very clean. And so I think it's really important to test in every environment with what the concentration actually is in the space so that you get a real answer. But kind of recognize the challenge here is that it will be a different answer in every environment. But that's reality.
Yeah. Yeah, so another question for you, Dusan, is that most of the indoor air quality monitors generally have this capability of comparing indoor air quality with outdoor air quality data. So essentially, we are trying to compare data coming out of a low-cost sensor with that from probably a high-grade outdoor air quality monitor. How do you look at this approach, and are there any considerations that we need to be aware of so that we draw in meaningful insight?
So we typically, well, at least for the research purpose, we are comparing, yes, indoor air quality low-cost monitoring with a high-grade sensors, and of course, as I mentioned in the presentation, most of this comparison is happening in the laboratory environment and not sufficiently in the field environment. And then I don't know if I fully understood the comparison with the outdoor monitoring. What did you exactly ask me?
Yeah, the data coming from outdoor air quality monitors compared with the data coming from our indoor air quality.
Yeah, but this is where I think it's a huge underutilized opportunity, as I mentioned, because both in the design, construction, and operational phase of the building, there is a huge untapped potential of utilizing outdoor air quality data set. At the design stage, we can make important design like decision, what type of ventilation we are going to use. Should we look into fully mechanical ventilation? Should we look into hybrid approaches or potentially purely natural ventilation? And we can also, my team has worked on a project about optimizing a selection of the filter grades, because probably in most parts of the world, we are under filtering the outdoor air, but there could be instances that we could be over filtering the air. So, or potentially we need to filter the air heavily in certain parts of the year and in other parts of the year not. Maybe we can use a bypass or lower grade filter. So there is a huge underutilized potential there, which yeah, this is one of the research priorities for the future.
Yeah. We have one question for Jeff. This is on air purifiers. How effective are they in naturally ventilated buildings? I'd also like to add a context to this in terms of, in cities like Delhi, we see a lot of air purifiers within the office malls, lined up. And so I wanted to also understand, I mean, this is in addition to the question that is posed. How do they effectively work in different kind of layouts and ventilation systems?
Yeah. So the short answer is if your air pollution is coming from outside and you have a naturally ventilated building, then you absolutely need air purifier because more air pollution will come in with that ventilation air and you need to clean it. And so it depends a lot on the quality of your outdoor air. To highlight something that Dusan just said, I think there's an opportunity for control here as well. You could have an air purifier with many of them already have an integrated low-cost sensor that turns on when the air pollution gets higher and turns off to kind of save your filter life and save some energy cost. And so I think there's a lot of opportunities like that. The other comment I would make is that, one of the things I think we as a community have to be thinking about is that performance really is variable over time. And so there are times when a naturally ventilated building will have a lot of ventilation air, and it'll be times where it will have less ventilation air just based on the wind and the inside-outside temperature difference and a bunch of other factors. There are times when there might be high ambient air pollution, times when there's lower. So it is really important to think about integrating some monitoring so that you're targeting your strategy to the actual conditions.
Yeah, we have another one for Dusan. This is related to guidelines. Are there any guidelines that, guidelines on calibrating low-cost IAQ sensors in terms of, I mean, what is the duration in which, or what is the frequency for calibrating?
Yeah, there's some existing guidelines and sort of emerging guidelines, mostly applied to outdoor air sensing. But unfortunately, as we could see from the literature review in practice, like we don't really stick to them enough, and there is a huge variability in how we approach things. And yeah, one of probably good approaches that I encourage my team to do is while installing sensors, we try to go to the real buildings and try to like mimic some conditions in terms of the concentrations and indoor climate conditions that will be actually encounter in the real study. And then we kind of do this type of exercise before and after deployment of these sensors in the field because of this sensor drift that can happen over time. It's very important to repeat that after the study is complete or after the monitoring is complete. Now, I'm of course giving an example of a research approach, but before and after or periodical calibration, it's very important. Some of the sensors comes with the automatic calibration systems, mostly for CO2 sensors. They also face certain issues, but yeah, in practice, they work decently well.
Great, thank you. The next question for Jeff is, we nowadays see DIY air cleaning solutions where you could have HEPA filters that can be strapped to a front-faced fan and then turn them into an air purifier. So have there been studies where the effectiveness of such solution has been evaluated and compared with commercially available equipment?
Yeah, absolutely. At this point, I would describe it as almost overwhelming research that a well-built DIY air cleaner, and you can find lots of plans and so on online, is every bit as good as, if not better, than many commercial opportunities for air cleaning. So I really encourage people who are interested in that to do it. I also think it's a great way to address some of the kind of knowledge translation issues or to get people engaged in this solution themselves. The two comments I would make about DIY air cleaners is one, we use them a lot in our research and our work with communities. And in some cases, there is a little bit of a pushback because they can be aesthetically not as nice as a commercial air cleaner. So people see them as a second choice solution. And there's a lot of good solutions to that. For example, some people kind of make nice looking housings that you slide a filter into. And so, but the comment I have is, if you're going to be doing DIY air cleaners, make sure you're addressing that aesthetic piece. And then the other comment I would make about DIY air cleaners is they do work fantastically, but the filters, like any air cleaner, will need to be changed at some point. And a lot of times the filters are taped in place, and it's kind of a process to change them. So if you are building DIY air cleaners, think about the aesthetic issues and think about the kind of maintenance issues, and then you will have a very, very effective air cleaner.
Sure. The next question to Dusan is, from the energy efficiency and grid management perspectives, there are efforts across the globe to scale smart grid interactive buildings. So when we do that, when we design such buildings, what are the considerations that we need to have so that indoor air quality is not compromised during that process?
Yes, well, indoor air quality should certainly be much more integrated in the very design, or we can even call it a life cycle assessment of the buildings. And well, many issues we are facing is that today is that we start thinking about indoor air quality a bit too late in the process. So of course, we're still far from having routine indoor air quality monitoring mandated beyond certain exceptions like carbon monoxide detectors and so on. So yeah, we need to probably move in that direction to start mandating both at the commissioning stage and regular performance verification when it comes to indoor air quality, both in the old construction and new energy efficient buildings. If we look at the best practices of the green building guidelines nowadays, one of the best examples is like performance verification once per year of indoor air quality. So yeah, we certainly need to shift towards more dynamic evaluation of the buildings, really performance-based approach.
Yeah. This is more of an awareness. The topic is more on the awareness bit, Jeff. So the question is, are there examples from around the world where awareness about IAQ is brought to schools?
Yeah, absolutely. So again, I'm most familiar with the North American context. I would specifically cite the US EPA has a ton of good information, or at least did. I assume they still do have a ton of good information on indoor air quality in schools, both from the technical side and from the knowledge translation side. The U.S. Green Building Council, the same organization that promotes the LEED standard, they have a whole set of information, again, both technical and knowledge translation based on schools. And I think there's many, many other examples around the world. The one comment I would make about schools is schools are a very interesting challenge because in a lot of the world, they're a public resource, and there's this kind of complication between an administrator who has to make a decision subject to certain constraints, and then you've got kind of these multiple constituencies of the kids in the school, the parents of those kids, the broader society who's paying for those measures. And so I think the evidence is overwhelming that we should be addressing indoor air quality in schools. And I think how we do it is where we need to think about this kind of complex political context.
Thank you, Jeff. We have another question for Dusan. Can low-cost sensor performance be verified by comparing it with a referenced or calibrated instrument used in the field? Or is there, what could be the methodology to do that?
Yeah, I think I already touched on this. So doing the performance testing in the field, it's always a better idea than in the usually static lab settings. And one thing is what we can do, you know, realistically, and the other thing is what we should be doing. So typically, what I encourage researchers and other people to do is to reproduce the field conditions as much as possible, whether to test actually the equipment in the environment where the monitoring will eventually happen, and then to do any kind of comparison over as long as possible period against the reference grade instrument in that settings, because there is a ton of evidence showing that even certain variables that we might not think about, such as like indoor relative humidity, can drastically affect, let's say, performance of the particulate matter sensors. The temperature can also cause major drift, and also the concentration itself and dynamic fluctuation of the concentration. So it's very important to do the test in as realistic as possible environment.
Thank you, Dusan. We have one question for Jeff. This is about how to decide which type of air purifier to be installed in a place. I also would like to add by saying, you know, we have different technologies currently, UVC lamp that is used for air disinfection. So how do we, how do we know which type, and then what has been the effectiveness of different kind of technology so far?
Yeah, so it's a huge question. So the first thing I would say is there's this three-step procedure. Step number one is deciding what you're trying to control. So you might be a UV system if you're trying to control certain microbiological compounds or things that cause infectious disease, for example. If particulate matter is a concern, as it is in much of the world, you might be using a conventional media filter, HEPA filter, or otherwise like that. Or if it's an odor problem or an ozone problem, you might be using activated carbon filter. So first you have to understand what you want to control, as well as something about your space. Are you trying to do something in a central system, in a room-based system, and how is that space used? Those sorts of questions. So once you answer that, the next question, or the next piece, is sizing that air cleaner. And for portable air cleaners, there's a ton of good sizing advice, either provided by the manufacturers or with various online calculators. For central systems, it's a little more complicated, but it's done all the time. So it's not a big challenge. And then once you've decided what you're cleaning, you've sized an air cleaner, and you've implemented, the third step is the step I talk a lot about, the verification step. Make sure it's working. So that's the short answer to a big question. But that process has been done, you know, literally thousands of times. It's done all the time, and it works when it's done. And so just because it's simple doesn't mean it doesn't work.
Yeah. Dusan, we have one question about IAQ monitoring in offices. Considering an office in India, what are the beginner level steps that can be adopted to kickstart IAQ monitoring?
So that's a great question. And beginner level steps, in fact, might not even include any indoor air quality monitoring. I think this is a very important point to bring to the audience, because a lot of indoor air quality issues could be resolved without doing monitoring itself, by doing various corrective actions and some kind of proper commissioning, maintenance, visual inspection, and so on. So I have been working on the new performance measurement protocol within ASHRAE, where we develop a 3-level approach to doing the performance assessment of indoor air quality. And in the first level assessment, which is the most basic evaluation, we can characterize indoor air quality at the most basic level and just identify certain issues and propose corrective strategies. There is barely any monitoring involved, and yet it is considered a very fundamental step. And then, of course, we can start building on that. We can start talking about putting some very basic monitors that can measure the most standard parameters out there. Of course, because we talk here about the office space in India, we should be probably thinking about monitoring particulate matters and CO2 primarily. And we can think about having a less dense network of monitors placed as a very first step. And of course, who is going to look into this data and make use of them in some way.
Thank you. I think we are approaching our scheduled time. So we'll take one last question, which is how does how does a natural air purifier like plants play a role in IAQ balancing?
Okay. This is a huge question, and I'm going to give as short an answer as I can. In many environments, plants do not make a difference to indoor air quality. That has been demonstrated quite well. And so, plants, we can see some behind Dusan in his office. Plants offer a lot of benefits for people's well-being and comfort and happiness in a space. In terms of their actual ability to treat indoor air, there has to be very specifically designed systems that put a lot of air through the plants, often that use soil and soil microorganisms to treat the air. And so an ordinary house plant doesn't change indoor air quality that much. There's a lot more I could say about plants, but in the interest of time, maybe I'll pause it there.
Sure. I think this has been an interesting session. We've had really good engagement from our audience as well. So I think before concluding today's session, I would like to thank our experts for sharing, sharing their research and experience and expertise with us. It was truly an enriching session, and I hope we all have some action points to take home to improve air quality in our own individual settings. And a big thank you to our audience for your active participation and engagement. Please follow us on social media to stay updated on upcoming dialogues. With that, we bring this webinar to a close. Thank you, everyone. Thank you.